All right, example 4. Let's kind of look backwards now. Let's talk about what if we were given the area and we wanted to find the z-value that's associated with that data. Okay, so reminder with z-values. With z-values, we say that the mean, this middle symmetrical point, is a mean value of 0. Okay, so that's the mean value of 0. We want to find what z-value will give me approximately 75% in the middle, which means that this whatever z-value is here, this will be a negative z-value on this side. That's such that I have 12.5% on each side. So let me show you how my calculator walks through it. So for a z, you're dealing with a mean that is 0 and a standard deviation that is 1. So I'm going to zoom in on this, and now I'm going to introduce you what I did not have turned on before, but now you'll see the rest of the way, is what we call the cumulative distribution function, which is going to be graphing how much area you'd have at any point in time. So on our value, we want to know when I have 12.5% of the area over here and over here, and I truly want 75% in the middle. Now, some students will incorrectly think, oh, I need to put in a negative 1.25 to have it on this left side and a 1.125 on the right side. That will give me my value. No, that's not correct. You can see the pictures don't match at all. So that's not it. So what do you do going backwards? It's something like an inverse. It's kind of like it's the inverse of this cumulative probability here. And so how does it work? Well, using this value, you can figure out where the value would be by looking at our A value and this number of tails. That's what I'm doing. Slide down where you can see this A and number of tails. So what is number of tails first? When you hear me say number of tails, it's talking about shaded regions here. And you're going to hear me use this term a lot in the coming days. Is I'm going to say there are 2 tails of data that we're looking at. So I'm going to take this value over here and make sure it's on 2. And now my A value is going to be the area or the percentage of that outside area. So A is going to equal 12.5% plus 12.5%, which is equal to 25%. Or we could say A is, for the calculator, 0.25. And that's what I'm going to type in here. A is 0.25. Now what happens is this calculator here is going to show you that the z-values are going to be these locations where these meet on this graphed cumulative density function here. And so to get 0.125 and 87.2, if you're wondering where's 87.5, it's 12.5 plus 75% is 0.875. You would have the x values or the z values of 1.15. So that's what my answer is going to be in this one. Z is going to equal 1.15. Now you might be thinking, well, one of them is negative, one's positive. Yes, the negative one is negative z. So negative z equals negative 1.15 and positive z equals 1.15. You know what that means? If you divided this by negative 1, that z is ultimately positive 1.15. So that's our answer here. Now, could we have done this another way? Yes. If you come over and you look at this z-score, I've already found that for you. As soon as you put in this alpha here, the z-score, that's what's calculating here. These are the z-score values. So in this particular case, we get that those 1.15s. The left z-score value was negative 1.15, and the right z-score, that means what z is on the left and the right, were 1.15. So let me show you this all over again so we can see it afresh. Part B says, find the z-value associated with the top 5% of data. So again, we know that the mean here would be 0. Anytime you're dealing with a z, that means the mean itself is 0. You want to find just the top 5%, which means this is only one tail. The data is only looking on one side. And so A is just simply 5%, that one side, which we could say as 0.05. So when I come over here to my tails, I'm going to change this. I'm looking at one tail, and I want 0.5. This is giving the values if you want the far left or the far right, where I'm getting 1.645 is z. This z value right here, that z value would equal 645? 645. Now let's come over here to the z-score and you look at it. If you wanted the 5% on this side, that would be your number, negative 1.645 is how they ran it. And when I clicked on the button, that's how they ran it to the nearest thousandth. But to the nearest hundredth, it would be 0.64. And then the same occurs for the positive side. If you want the top 5%, that would be your z value. So, you know how they normally list it. I should show this. Find the interval. Since it's saying the interval associated, you would just say that z is less than 1.645 is how I should have set it as an interval. And so let me go back. Did that one say interval? It did. So that's my z value. That means my z's need to occur between negative 1.15. And so I'm actually going to write this answer as negative 1.15 is less than z, which is less than 1.15. That's actually the way the answer would need to be written here. I messed up. I'll just have to erase that. Putting that boxed around the 1.15. That's not an interval, that's an exact value. So let's make sure we get the answer in the right form. That's what z equaled. And so we want the z value to be anywhere in between those two values to get the 75%. So now that you've seen it twice, I'm going to let you try on this one, see what you come up with. Pause the video if you need more time.